And also different water quality if you want to use it to wash your clothes, for instance. Nak basuh baju, okay? You wanna apply, what do you call this? Water your plants, okay? For cleaning purposes, different kind of water quality, you see? For drinking, you need to have a very good water quality, all right? So that you don't get sick. You don't get any kind of salmonella attack, for instance, bad bacteria in the water supply, you know? Your water needs to be very clean, no organisms, pristine, all right? Now, when you want to water your plants, you don't need that kind of water, not that clean. It's okay. You can even you can water your plants with water that you use to wash your fish. Actually, once you clean your fish, some people use that, right? They clean their fish, they gut their fish, air ikan tu dia ambil, dia bagi siram kat pokok. Betul tak? So the water quality, water quality that you use to give your plants is different. You need a lot of nutrient for your plants. And then the water quality that you need to wash your car, for instance, you know, for bathing, at least it should be very clean, no turbidity. You know, can you imagine, I guess, if you take your bath this morning and water come out, yo, look like teh tarik. How can I take my bath? Water like teh tarik, man. Look, the water looks like the river look like the Sungai Pahang River. Siapa sini orang Pahang? Anyone? Izzah orang mana?
Saya, Doktor.
Atira orang Pahang kan?
Muaz.
Pahang kat mana? Where you? Whereabouts in Pahang?
Kuantan. Kuantan.
No. Okay, Kuantan.
Tira Husna, sir.
Tira, betul lah. Kuantan. So if you are in an area in Pahang where you have this Sungai Pahang going through your area, like Temeloh, for instance, or some parts of Pekan, you'll find that the water quality in Sungai Pahang nowadays is getting worse and worse, you know. Air Sungai Pahang sekarang banding compared to 10 years ago, 20 years ago, is getting more yellowish, more turbid, and looks more like teh tarik, especially during the rainy period. Okay. So that is why all the farmers that grow fish in cages in Temeloh, you know, Temeloh is a very important place. They supply a lot of patin, ikan patin, or your catfish, or your pangasius catfish to the market. All right, people like to eat ikan patin also. But then a lot of farmers having issues with the water quality. A lot of turbidity in that river, yeah, guys? You mentioned about turbidity, and there's a lot of issue there in turbidity, especially during the monsoon, during the season where you get a lot of water, monsoon, okay? And people there, I was there a couple of weeks ago, they told me the water quality in Sungai Pahang is far, far poorer than they were before when they start to grow the fish. And the fish can easily get sick nowadays, all right? So that is also very important to look at, and also important role for us, all of you, as you go out there. Once you graduate from UPM, you all have a role to play, you know, as aquaculturists, to make sure that people don't just clear off our jungles, you know, and pollute our environment, because the effect to our aquatic system is detrimental, is very bad. All right. So kita semua ada peranan tau, nak pastikan sumber air kita terjaga. Alright. I always tell my children and then all my family members, you know, must take care of your water supply. Don't pollute our water supply. Alright. Okay. Now, when you talk about water quality also, alright, I just want to pick up that point from Mashita tadi. As I said, different users of water, of course, require different kind of quality. Even in aquaculture, if you grow fish in a fish tank, the water quality in a fish tank is different from what you have in a fish pond, which is open to the sun. If you grow fish in a fish pond, which is exposed to the sun, you'll find that there's a lot of microorganisms, phytoplankton, zooplankton in the water. That's why the water is green in a fish pond. But if you grow a fish in a tank, especially which is a bit covered, or indoor system like your aquarium in your house, you don't want those green stuff, do you? You don't want any phytoplankton. You just want the water to be very clean so that you can see the fish. You're not interested in growing the phytoplankton. But if you grow a fish in a big pond exposed to the sun, then you want your phytoplankton because the ecosystem is already very different. You guys get it? Yeah? All right. So the term water quality is different for different reasons, different purposes. Now remember the purpose of your water that you want to use it for. So for consumption different, for drinking different, to grow fish is different, and so on. Okay, now having said that, I think I also taken your attendance right now, and Atira will assist me as well. Why don't I go ahead and start my slide and then go into the bit more detail on water quality, yeah? All right. Can you guys hear this?
Yes.
Yes.
Yeah. Good. Thank you. All right. So now, first of all, what is water? All right. To me, it's a miracle liquid. All right, that supports life. And then, if for a Muslim, you know, when you read a chapter Al-Anbiya in the Quran, it says that we made water from water every living thing. I mean, whatever is living has water in it. You see, if we human beings, we dry ourselves, let's say you go into a desiccator or you get dried out, only about 20% of your initial weight will remain, you know. 80% is gone. Meaning that if you're at now, your weight is 50 kilogram. I know some of you girls are about 50 kilogram only, you know, about that weight. If you dry yourself, if you know, for instance, if we dry ourselves and really get very, very dry, remove all the water, your weight will be reduced to about only maybe 10 gram. From 50 down to 10 gram. Can you imagine that? You know, the rest is water. Okay. And for Christians, you know, in Genesis, it says that let the water swarm with swarms of living creatures. Also, in Hindu, Artha Veda, water is good. Water indeed is fatness, and readily flowing water whose scatters sweetness come into me with breath and vigor. So there's a lot of good things talk about water in all the scriptures, you know, whether for the Muslims, the Christians, the Hindus, you know, the Buddhists, and so on. So it's very important, as I said earlier, and when we start the class, that when you look at water, please don't just look at just alama air, man. You know, it's more than that. It is the origin of life, you know, and it's without water, you know, you can survive. That's it. That's important. You know, in Selangor, for instance, the state of Selangor, we have this water disruption every month. You know, it's like a scheduled water disruption. You know, they can schedule already. Okay, by this time we're going to disrupt your water supply to do some maintenance lah. And then sometimes it's not even a scheduled water disruption. They got polluted for some reason by ammonia level very high. All right? Okay, so can you imagine the kind of stress, the challenges faced by a lot of people when there's no water? So again, that's why I said, whatever water is very precious, and we must take care of it. You know, let's take care of our source of water. I do hope that the people who run the country, the politicians, you know, the head of departments, especially involved in water management, they really think about this, all right, and do their part to make sure that our source of water is clean and suitable for all of us to drink, to do our activities, and so on. All right, so as I said, water is important for drinking, washing, fisheries, transportation, hydroelectric industry, firefighting. Imagine you want to fight fire, tak ada air, no water. Agriculture, definitely. Recreation, you know. Some of you, after this MCO, I'm sure some of you are planning, or have already planned with your family to go on vacation. And a lot of people go to the beach side, go to riverside, you know, and enjoy the river, enjoy the water. All right. So can you imagine even you want to enjoy all those activities and the water quality is really below your expectation? It's very poor. All right. Now, look at our planet. More than 70% of the Earth's surface is water. That is why they call it the blue planet, you know. Earth is the blue planet. Oh, there is a red planet. What is that red planet called?
Mare.
Mars. Right, Mars. Huh? When you look at the sky, sometimes you can see Mars, you know. Do you know that? You know that you can even see the red planet at night, during a dark night. A couple of weeks ago, I saw the very bright light at night. And I said, wow, this look a bit yellowish. It's actually Mars, you know. Okay. There's an app now. I'm sure you know about this. If you're interested to look at the stars, you can download a lot of apps, right? So I have this app on my handphone. And then when I want to look at the sky, I say, oh, okay, what is that? Oh, that's Mars. That's Venus, you know, and that's the Andromeda, all sorts of, you know, constellations and so on. I hope you guys, you know, interested to look at that as well. So it's interesting to see the skies at night, especially during the moonless night. All right, so look at the water distribution here. You see, in the ocean, okay, you have about 97% of where our water is, and then 3% is fresh water. Can you imagine? Only 3% of your water volume on Earth is fresh water that you use. The rest are all salt water. And of that 3%, 75% or 76% here is covered with ice. The rest is your water vapor. The rest lakes and rivers, deep groundwater and shallow groundwater. All right? River and lakes also not much. Okay? And only 1% is fresh water available for human consumption. Of that 1%, 95% of it is groundwater. So it means only 5% is surface water. What is surface water? Your river, your what do you call this? Your lakes. All right. So can you imagine? Very small amount of water is available for us to use for our daily consumption, you know, for our daily activities. So that's what I said. Must take care of your water sources, water resource. Okay. This is where fresh water, most of it can be found. This is in the icebergs, you know. And this is not salt water. This is fresh water. The ice, yeah, the ice cap, the polar ice cap, the North Pole, South Pole, all of this. This is what this is frozen fresh water, not seawater. Fresh water floats on the sea. Look at that. Yeah, look at an iceberg. Most of it is under the sea. Only like 1/10 or 15% of it is above the water. The rest is below. So that is why, if you learn about the Titanic, right, which sank many years ago, this Titanic were actually applying the water very close to this iceberg, and then it hits the iceberg at the bottom here. Yeah, even though it is not close yet to the top, but it hits already at the bottom. And you know this tragedy, right? On the Titanic. Okay, they even make a movie out of it, right? Well, some countries say, hey, you know, if there's a lot of fresh water in icebergs, why don't we harvest them? Why don't we harvest them? Why don't we take iceberg, transport them to our country, transport them to in the Middle East, where there's not much water, anywhere where there's no water, how do we transport them? Fresh water. All right. What is the issue here when you transport water from the icebergs, from the polar ice caps to various countries? What could be the major problem here?
Melt.
Yeah, of course. Yeah. Well, as the water, as you pull this massive iceberg out, from the polar ice cap, take it out, and bring it down to places or countries where they need a lot of fresh water, they melt along the way a lot. Okay. And at the same time, you need a huge number of boats to actually pull this along, tugboats and so on, all right, to assist when you want to pull massive icebergs. They thought about it, about iceberg harvesting, and then they say, no, it doesn't make any practical sense or economic sense. It is better just to use your seawater here to actually convert the seawater to fresh water. So that is why in some countries, like say in the Middle East, like in countries where there's not much fresh water, no river, no fresh water river, very little. What they do is that to get fresh water, they take the seawater and undergo a process called desalination. Desalination, okay? They remove the salt and they extract the fresh water. All right, so that is a better or more viable option than doing all this, okay? Okay, now, as I said just now, most of our water is in the ground, all right? And in the ground, we have a place called aquifer. This is a saturated zone with water, aquifer. So if you want to take groundwater supply, pump water from the ground, that pipe that goes down into the earth, that pipe, let's see, this is a pipe that goes down to the earth, it has to reach what we call as a water table or saturated zone, or another term for it is called aquifer. Aquifer is a pool of water under the ground, all right, your water table. So once you reach the pipe down to the aquifer, then you can pump out the water, okay? Well, we have what we call as the water cycle. Now, when you talk about water cycle, there is no beginning or the end. All right, so water, as you know, we learned this from Form 5, I think. Water changes its states from liquid, vapor, and ice, depending on the various places in the water cycle. And what drives this water cycle is none other than our sun, ya. Matahari lah yang menggerakkan sebenarnya siklus atau kitaran air ni di satu dunia. Sebab tu dia berubah dari liquid, cecair, vapor, uap dan ice. Okay, so all these changes in various states, water states, is driven by the sun, and at any time you have all these three depending on where you are on this earth. All right, so you see this, you have water that evaporates from the sea. Of course, if you get rain that falls down on the ocean, it evaporates, condense, and become your cloud, okay? And your cloud get blown away by the wind near to your to the land, towards the land, falls down as rain. Even the snow melt off as runoff, the glacier, all this. All right. Now some water will undergo a process called sublimation, meaning just become vaporized. It vaporized, called sublimation, and becomes what do you call this? Part of the cloud cover. All right. And plants undergo a process called evapotranspiration. Right? It transpired also, and the water goes up. as well. Okay, and the water that falls down as rain will go into your stream, your river, your lake, and quite a lot of them will go down and percolate. Percolate means the term they use. It means it goes through the stones, goes through the rocks into your groundwater supply, and all goes back to the ocean, and it's recycled. All right. Okay. So as I said earlier, when you look at the component of living things, we human beings, most of our weight is water, 75%. But then if you look at bacteria and other microorganisms, can you imagine 85 to 90% of your phytoplankton, zooplankton is made up of water. Okay. And this is very important. How many glasses of water should you drink a day, guys?
8.
8 glasses.
Yes.
All right. So is that 8 Coca-Cola, teh tarik, and your
No.
100 plus? No?
So,
Mineral.
Okay. All right. So that 8 glasses of water is plain water. Plain water, yeah, you said mineral water, water from the tap. Okay. No sugar, no additive, no nothing. Just plain good water. All right. Why I'm saying this is because a lot of us like to drink sweetened water. Okay. So nowadays in many shops they sell all this what do you call this? Tea Life lah, whatever, all this. What was it? Is it called what? Jojoba? What do you call that? What?
Cocoba.
Cocoa. Okay. The young ones like all of you, I'm sure that you know about all these sweetened drinks with jelly balls and all these things. Jelly balls lah, tapioca balls lah, all the sweet stuff. All right. So that should not include in your 8 glasses per day. Your 8 glasses should be really pure, clean water, good for your cells. Good for your cells and good for your body too. All right. So those sweetened water, all those teh tarik is in addition to it, So try to drink a lot more fresh water, mineral water, more than all the sweetened water. Okay, this is I must put this because this is my favorite character, Patrick. Yeah, this is one of my favorite character, Patrick, and of course SpongeBob. Okay, see, when they go out of water, also they need to to put on this flask, okay, and have some water to breathe. Also, so funny. This is a picture I took from Google, of course, but it shows that when they're out of ocean, they still need to have some water supply. All right. Now, water contains larger or smaller concentration of all elements found on the Earth's crust, all right, and in the atmosphere, and is extremely varied in chemical composition and very much influenced by geology and climate. You see, when you some of you okay, now siapa tadi? Who's driving down just now? Siapa tadi? Who's driving down from Kedah to Selangor?
Me, sir.
Siapa nama tu?
Shafini.
Shafini, right. Now, Shafini, as you drive down, your father driving the car. So as you drive down from Kedah to Selangor, and you will pass Ipoh, right?
Yeah.
Pass Ipoh, and you look to your left and your right, you will see these outcrops, left and right. These outcrops called the limestone outcrops. Limestone, okay? Bukit Batu Kapur, okay? Now this Bukit Batu Kapur limestone outcrops is very much a feature in Perak, especially near Ipoh side. So that highway that goes from Kedah down to Johor will pass through a lot of geological features. Okay, and one of it, of course, you go through Kedah, you see a lot of flat land where you grow your paddy fields. And then you don't see much towards Penang side, but once you hit Ipoh, okay, you will see on your left and right, you go up a hill, and before you go down the hill, you can see left and right all these outcrops. Those are what we call as limestone outcrops. Now, that is quite an interesting feature. So in when you have that limestone outcrop in places where you have that, you'll find that the water is quite alkaline. Okay, alkaline means what? Means the pH tends to be 7 or higher. Okay, now we'll talk about more alkalinity later on in the class, but you can see this. All right, so that's why traveling is very interesting. You know, sometimes you don't care so much. Okay lah, go Bukit left and right, but you think about it. Yeah, this Cik just told me this limestone outcrop. So no wonder lah the water in Ipoh and Perak are mostly alkaline water. And also, no wonder lah, a lot of fish that they culture in the country, in the peninsula, do well in Perak. Do you know that Perak is the #1 state in Peninsular Malaysia that produces freshwater fish? Do you guys know that? Guys?
I just know about it.
You just know about it. Yeah,
I thought it's Kelantan or Terengganu.
I know.
Because they're like
Perak is the #1 state in Peninsular Malaysia, okay, that produces freshwater fish. Of course, if you mix everything up, even Sabah and Sarawak, I think I have to look at the stats, but I think Sabah and Sarawak also is slightly less than Perak. For some reason, Perak has the most production of freshwater fish. And it is also very much related to the geological nature of the state of Perak, okay, where the water goes through your limestone, earth with a lot of limestone. The water has good alkalinity, the pH is very stable, you know, and that is good for fish culture, right? And, you know, that is also why in Perak they grow a lot of this ikan arowana in Bukit Merah, where the water is also quite stable pH and quality of water is very good. All right, so you see, that is also a bit related to the geological climate or geological nature of the area. Okay, as we go down, I'll give you a bit of geology scale. Yeah? As you go down from Perak, go down towards the Selangor border, you will see that still a lot of river. So that is why in Perak, a lot of people will go to Perak for rafting lah, for jungle trekking, because that is where you see a lot of mountainous areas. Okay, and then if you have some time, you go to a place called Gua Tempurung. Do you guys know Gua Tempurung?
Yes.
Yes. Now you go there for caving, right?
Yep.
For caving, and then you go there, and then you can see that in Gua Tempurung is also a limestone cave inside there. Yeah? You can see your stalagmite and stalactites inside there. All right. So there's a feature of this area. Okay, Gua Tempurung and Gopeng, and as you go down further in Selangor, you find less and less of that particular geologic outcrop or geological what do you call this structure. Okay, all right, and then you go down further from Selangor, you go to Negeri Sembilan, you see less and less of this, and then towards Johor is a bit different. Johor is a bit more flat, especially where you have your highway. Okay, and then you go up towards Pahang, let's say Kelantan and Terengganu, Kelantan. Kelantan, Terengganu is more sandy. There's a lot of sand, sandy beaches and so on. It's a bit different, and also different kind of water quality. All right. So those areas like in Kelantan and Terengganu, the where you have a lot of sandy soil in some places, the water tends to be a bit more acidic in places like that. Okay. All right, so it's a bit different. Doesn't mean that it's good or bad in other states. It's just to tell you that it is also related. Where you grow fish is also quite related to the water quality of that particular area as well. All right. Okay, so climate as well. Climate, like in Malaysia, our climate is good. We can grow fish 24/7, 365 days a year, 12 months in a year. We can grow fish, no issue. Our only problem would be, is it too hot, okay, or too much water? All right. So, so people ask me, Abdullah, what do you have any seasons in Malaysia? I have some friends in overseas, so they have like winter, spring, summer, and fall, the 4 seasons of the year. They ask me, Abdullah, do you have those kind of seasons in Malaysia? Well, I said, no, we don't have those seasons here. We only have 2 seasons. One is the hot weather season, and one is the wet season. That's it. All right. None of those 4 seasons that they experience in other countries. It's either too hot or too wet. So these are the substances that you find in water, different kinds of gases. Of course, a few of you said dissolved oxygen. Okay, very important. In fact, dissolved oxygen is number 1 critical, what do you call this, limiting factor in water quality management. Okay, so when you want to grow fish, the number 1 water quality parameter that you want to make sure is good for your fish is dissolved oxygen. Make sure you get that right first. Okay, guys, dissolved oxygen. Itu yang sangat penting. Okay, the rest comes after that. Okay, dissolved oxygen is the number 1 most limiting factor in water quality for fish culture. They have minerals, soluble organic matter like humic acids, tannins. Now, humic acids are the ones that color your water black. Tannins also brownish. Okay, it is why when you grow some fish in the aquarium, let's say, some of you put down ketapang, for your betta fish. Okay, this particular leaf, which is brown in color, down ketapang, to increase the humic acid or tannins, the water will become brownish in color. As the tannins, extract comes out, the humic acids come out, the water become a bit brownish, and the pH also will drop to around 6 or 5. So some parts of Malaysia, okay, and the north part, let's say the north part of Selangor, there's the northern Selangor pit forest. Any of you from Sabak Perenam here? Selangor? Or Kuala Selangor? Anyone? Ada tak? Tak ada. Okay. So if you're from that area, especially in Sabak Perenam, between Sabak Perenam and Tanjung Malim, you'll find there's an area called North Selangor Pit Swamp or Pit Forest. Now the water there is quite black in color, blackish. And there's a lot of fish that grows there, even though the pH is quite low. Fish like your betta, your tiger barb, your tiger barb, and some catfish and so on. Yeah. So even though the pH is quite low, it can come down to 5. You can still see fish growing there. All right. So different kind of environment, different fish species. All right. And suspended inorganic matter, you do have some, which is like your clay particles. Now, the color of your water in Sungai Pahang is brown like teh tarik. That is due to your suspended soil particles, mostly clay particles, tanah liat yang terampai. Tanah liat yang terampai, your clay particles that is suspended in water, that cause the water to become brownish in color. And other than that, you do have suspended organic matter, like some of you mentioned just now. Your organisms such as living plankton, your fungi, your bacteria, and so on. So these are the common substances in water. Your gases, your minerals, your organic matter, which is soluble, that color the water black or brown. Your suspended inorganic matter, like your clay particles that make it like teh tarik. And then you do have some suspended organic matter that can make it brown also and green, when you have a lot of phytoplankton. All right. So these are the common substances in water, the ions, which can contribute to the salinity of the water as well. Some of you mentioned salinity, right? You have bicarbonate, chloride, sulfate, all these things. And the concentration of major ions are much greater in seawater than in freshwater. So you have a lot more concentration of ions in seawater. Your ocean is like a sink, As the water flows down the river, flows down your lakes, all the ions are concentrated in the sea. When the ions concentrate, you have a lot of sodium, potassium, all these things, carbonates, bicarbonates, nitrates, nitrites, sulfates, all this, and it becomes saltish. All right, so that is why oceans and seas tend to be salty compared to your freshwater in the river. Now, when you measure salinity, okay, you measure it in a particular term we call is parts per thousand. Have you heard this term before? PPT, have you? Or have not? Has anybody heard this term PPT or ppm? Siapa-siapa pernah dengar term ni? Hello?
Tak pernah je lah.
Parts per thousand or parts per million, if I'm not mistaken.
Yeah, but most of you have not heard about it, I suppose? Atau pernah dengar? Yang lain macam mana?
Pernah dengar je.
Tapi tak
Dengar tapi tak tahu.
Pernah dengar tapi tak tahu. Right. So take this down. Hey, by the way, you guys should have your notebook, man. Alright. Okay, even though I will share the slides, but please make sure you have your notebook, because some of these things like I said, are not in the slides, like just now I mentioned about certain things. They're not in the slides. So take note of what I say, and then refer to the notes also for certain things as well, okay? So when you look at this term called PPT, it means parts per thousand, bahagian per ribu, bahagian per ribu. And then you have ppm, which means parts per million, bahagian per apa? What is part per million bahasa Malaysia?
Juta.
Yes, bahagian per juta. Okay. So parts per million, parts per thousand, and of course percentage is parts per hundred. Okay, you don't normally say parts per hundred, but you normally use that particular symbol as percentage. So when you look at percentage, it means also parts per hundred, bahagian per ratus. Okay, so bahagian per ribu, bahagian per juta, bahagian per ratus. That symbol, percentage. Now, seawater is very salty, right? So the salty seawater normally has a salinity concentration, okay? Salinity concentration of about 30 to 35 parts per thousand. Brackish water, 0.05 to 30, and below that is fresh water. All right, so that means your fresh water obviously has very little salt in it compared to brackish water, which has a bit more, and the most of it is in your marine water or saline water, they call it. All right, so salinity is not, no more than a measure of the total concentration of all ions in the water. So that is why your ocean and your seas is very salty, because there's a lot more ions all inside there, like a sink. Okay, and the salinity of your brackish water ponds near estuaries are normally influenced by your river discharge, especially during wet and dry season. When you have a lot of rain that comes down and the flow through the river to the ocean, you'll find that the salinity of your brackish water near the estuaries becomes a bit more fresh. Salinity is less. When there's less rain, a lot of sun, becomes hot, the weather is hot, you find that the salinity of brackish water is higher. So the changes in salinity of your brackish water, okay, is very much affected by the seasonal changes of your rain and your wet seasons, okay? Okay, now I asked you this question in the beginning, right? The meaning of water quality, and it refers to the suitability of water for a particular purpose. What is your purpose of using the water for? Is it to grow fish? And if you grow fish, is it growing fish in a pond which is exposed to the sun, where you have a lot of phytoplankton that will grow there? Or is it growing fish in a place where there's no sun, indoor system, where you grow your fish in tanks or fish in aquarium? So obviously the water quality is different for both areas. And water quality for us, human beings, to consume is different also, compared to water quality that you use to wash your car, to water your plants, and so on. So again, the term water quality refers to the suitability of your water for the purpose that is intended to, okay, for a particular purpose. What is your purpose of using that water? And what kind of water quality do you need, okay, for that particular reason or purpose? All right? Okay. And when you talk about water quality, it includes all the physical, chemical, and biological factors that influence the use of water for its intended purpose. Physical factors, the color of the water, that's physical factor. You look at it, hey, is it green? Is it blue? Maybe you can find it blue, sometimes. Okay, is it green? Is it red? Red can be dangerous. Why is it dangerous when you find your water sometimes near the seashore? It's red in color. Why could it be dangerous? Huh? What do you think? Why is it that sometimes you have issues with some of fish cages, the fish die when you have phytoplankton bloom? What caused that to happen? Recently also people say in the newspaper you cannot eat your cockles because of certain, issue with your water quality. What is that? Any idea?
And nitrite
Yes.
spike.
So when you look at such reports from newspaper, you find that certain times of the year, when you have a lot of nutrient coming down from the river to the ocean, especially in brackish water area, your estuaries, you have what we call as phytoplankton bloom. Okay, and this particular bloom is normally called HAB, harmful algae bloom. HAB, harmful algae bloom. Now, why is it harmful? Because such microalgae, certain like the dinoflagellates, okay, tend to produce toxin. Okay, tend to produce toxins which will cause your fish to die, which will cause humans also can die also if you eat too much of your seafood, especially we take clams or what do you call this, mollusks or cockles that are infected or affected by this phytoplankton bloom. Okay, so the phytoplankton bloom tend to cause the water to become reddish in color in some places. So that is why they call it in some places, what is the term that they call it? I'm sure you heard about it before. When the water of your estuary or certain parts of the ocean become red in color due to a particular phytoplankton bloom, you call that what?
Eutrophication.
That process is called eutrophication. And then that phenomena is called red tide. Pernah dengar tak?
Pernah.
Red tide.
Yes.
Okay. REDTIDE. Red tide. In bahasa Malaysia, we call it air pasang merah. Air pasang merah, red tide, is essentially caused by the abundance or overabundance of harmful algae bloom, principally of the particular genus called dinoflagellate, particular group of phytoplankton called dinoflagellates. They produce toxin, and that particular toxin is harmful to marine life and also harmful to humans if we eat the fish there and also eat the, what do you call this? The animals that we catch there near the area where you have the red tide. So be careful about this. Huh? All right. So again, that is the chemical factor, the biological factor, the physical factor, all influence the water quality as well. Okay. Now remember, often the aquaculture water quality does not equal to environmental water quality. Why is that so? Because the quality of water that you want to grow your fish in is different from the water quality that you want to enjoy for recreation, which is good for the environment of the natural ecosystem. Now, in aquaculture, what you want to do is to grow fish in a confined area, right? And you feed the fish, right? You feed the fish, you want them to grow, okay? And you make sure that they're healthy. Sometimes you treat the water, put some probiotics lah, put some chemicals lah, and so on, whatever. So that water that you grow your fish will tend to be turbid. Okay, like Yagis mentioned just now, tends to be turbid. Brownish in color, yellowish in color, or greenish in color is turbid. Why? Because that is the ecosystem or the environment which is good to grow your fish and is healthy growing in there. But that water which is turbid, green in color, brown in color, is not good for recreational purposes. They say you want to take, go on vacation near the seaside, near the estuary, you want the water to be very clear, right? You don't want it to be very green with phytoplankton. You want the environmental water quality to be good. So that is different. And also, if you have a lot of water that is of a high nutrient coming out of your fish pond, going to the estuary, going to the river, now that water will tend to have a lot of nutrient, and that will affect also the environmental water quality. Then you have, like just now you mentioned, eutrophication. So the aquaculture water quality, when you remove the water, you might have issues of what we call effluent, the effluent discharge from your fish pond, which will cause your environmental water quality to become poor. All right. So again, as I said, remember, your aquaculture water quality is different from your environmental water quality. That is why aquaculture is also considered as a source of pollution. Now remember this, guys. Remember, ingat ni. The water that is discharged from aquaculture facility is considered polluted water if it is not treated. Air yang kita keluarkan dari projek aquaculture, daripada kolam aquaculture, sekiranya tidak dirawat terlebih dahulu, ditakdirkan sebagai air yang mencemarkan. Remember, okay? Alright, so that is why for the water to have good standards and good for environmental water quality, if it comes out from the farm, you must go through certain practices, go through certain procedures. Okay, kalau kita nak buang air kotor dari kolam, yang banyak dengan phytoplankton, zooplankton, yang kotoran tu nak buang ke dalam sungai, terus pergi ke estuary atau pesisir pantai. Kalau kualiti dia tidak elok, kita kena rawat dia dulu. Kalau tak, dia akan merosakkan kualiti alam sekitar, kualiti air alam sekitar. So remember this, okay? The water that you discharge from aquaculture facility is considered a pollution to the environment. And aquaculture is considered an activity which pollutes the environment. Aquaculture juga adalah salah satu aktiviti ekonomi yang boleh mencemarkan kualiti air. Okay? Kita guna air, tapi kita boleh mencemarkan air juga. Do you guys get it? Boleh ya?
Boleh Cik lah.
Good. Remember this, okay? So we want to grow fish, fine. We want to make them happy. At the same time, remember, as we go through our activities growing fish, the water that we discharge or throw back to the river is also polluted, and we need to take care of that as well. So I will tell you later on as we go along what are the ways and means to treat your water and to make sure that your water that you discharge back to the ocean, to the river, follows a certain basic guidelines and quality management. Okay. Okay, let's stop here for a while. I want to take my cup of coffee and give me about 10 minutes break. We'll come back around 10:20. Boleh guys?
Boleh.
All right. So catch you later in 10 minutes. Good. All right. All right. So let us continue with this. Okay. Right. So when you talk about water quality, guys, you need to look at three aspects of water quality, three different areas. So not just the water quality of the container or the space where you grow your fish. So kalau kita cakap pasal kualiti air, kita kena lihat lagi tiga sudut, three areas, okay? One is the quality of water at source, meaning the source of water supply. Sumber air itu sendiri. Okay, sumber air itu kualiti dia bagaimana? Elok ke tak elok? Sesuai ke tak sesuai untuk kegunaan kita. So number one, when you talk about water quality in aquaculture, first, what is the water quality of the supply? The water that you want to use to grow your fish. So your water source can be from your river, from your groundwater, from your tap water, from the rain, whatever. So that is the quality of water at source. Number two is the water quality requirement in the culture system. What do you want to grow? So let's say, for instance, you have a fish pond and your water supply is from the river. So that is your influent, your source of water. So you pump the water into your fish pond. Now you grow your fish inside the fish pond. And this already in the culture system. Okay? So sistem ternakan. So kualiti air dalam sistem ternakan berbeza dari kualiti air dari sumber dia. The quality of the water which is in your culture system may be very different from the water at source. What does your fish need for it to grow well? What is important for the well-being of your fish? What temperature? What salinity? What kind of dissolved oxygen that you want? Does the fish need a lot of phytoplankton? Is it necessary to have the phytoplankton for that matter? Do you need to feed the fish? When you feed the fish, the water becomes turbid. You have excess feed sometimes. The fish will defecate, will produce waste, okay, and that will increase your bloom of phytoplankton, zooplankton, your bacteria in the water, and all those things. So the water quality requirement in the culture system is different from that outside or influent. Okay, when you grow fish in cages, for instance, in cages, all right, there is a bit of a problem because your water quality in the cage, in many cases, is very much the same as the water quality from the source because your cage is in the river, is in the water floating in the river. So kalau you ada sangka, kualiti air dalam sangka tu mungkin tak berbeza jauh dari kualiti air dari sumbernya, dari sungai itu sendiri. Itu yang masalahnya. Apa masalah dia? Kalau air yang sungai itu kotor, tercemar, maka air dalam sangka itu pun akan jadi kotor dan tercemar. Tak ada kawalan di situ. So when you have your water in the river, the quality is not good. Your water in the cages also is not good. And if it's polluted, your fish will get the harmful effect of the pollution as well. And the third point or third major area is the water which you discharge from your aquaculture system, which is the impact caused by your aquaculture effluent. Okay, you faham ejaan ni? Influent, in is the water that comes into your pond. Effluent, EFF, effluent is the water that goes out of your pond. So, as much as you want your water quality at source or your influent to be very good, you want to make sure that the water quality that goes out of your pond back into the ecosystem, back into the river, to be of good quality as well, because if it is not good, it will impact the ecosystem outside of your pond. Sekiranya kualiti air yang kita buang daripada kolam aquaculture kita berkualiti rendah, kita boleh mencemarkan alam persekitaran dan ekosistem haiwan lain di luar aquaculture system kita. Remember, the fish and the plants that grow outside your aquaculture system in the river and so on, by nature, they grow in an environment that is already ecologically stable. And now you put in some dirt, you put in some turbidity from the pond, and that will impact the ecosystem already present there. Remember this, alright? Jadi kita akan lihat 3 faktor, ya, 3 sudut: sumber air, kualiti dia, kualiti air di dalam kolam ataupun ruang ternakan, dan kualiti air yang kita buang balik ke dalam ekosistem. So these 3 areas are very important for us to look at when we talk about water quality in aquaculture. When you say about, just now you mentioned about pH lah, temperature lah, DO, I suppose in your mind is the water quality of your fish that you culture, the environment that you culture, your system. But remember, you need to make sure the water supply is suitable, and also the water that you discharge or you throw out back to the river, the effluent, is also suitable for the living things that is already in living there as well. Okay? Now, just to look at this, I'm going to show you, okay, picture. So that is water from your water supply, your inlet. This is called a feeder canal, where your water comes in, your feeder canal. And then you have water in the pond. Where the water comes in is called the inlet. Where the water goes out is called the outlet. Inlet, outlet. The feeder canal is the canal here that allows water to move in from your river here, from the water supply. This is the water intake, where you cut off here so that the water comes into your feeder canal. All right? Some people call it feeder channel. It's fine. Feeder canal, feeder channel, it's all right. So, water goes here inside this pond, goes out here. So, you want to make sure the water quality is good here at your water supply, here in the feeder canal, here in the fish pond, and also outside here after you discharge it, the effluent that goes out back to the river. All right? So all these stages are very important in terms of water quality management. Dari segi pengurusan kualiti air untuk aquaculture, kita lihat air dari sumber, air dalam kolam ternakan atau ruang ternakan, mungkin sangkar, mungkin tangki, tak kisah, dan air yang kita lepaskan, yang kita keluarkan semula ke dalam sungai. Okay? Alright. Now, since fish is totally dependent on water to breathe, feed, grow, excrete waste, osmoregulation, reproduce, and so on, it is critical for you to understand that, you know, to manage the water quality very well. All right? When you talk about water quality, there are a few areas you want to look at in terms of water source. Remember I talked about this? Water source, the influent. We talk about this first, okay? So we talk about water source first, and then we can talk about water quality in the system and water quality that you discharge from your system. So water source, right? So when you talk about water source, you can classify it under two. One is called surface water. The other one is called ground water. Surface water comes from stream, river, irrigation, and so on. And groundwater is, of course, your spring or your well, mata air, and so on. Bahasa Malaysia, some call it air mata air kan. That's called from the spring water, spring water. Now, surface water comes from this. Remember, I show you the hydrologic cycle. Kitaran hydrologic air. Because most of it starts from your rain. Mula dari hujan, hujan. So hujan turun dekat gunung pergunungan, Kemudian dia menjadi air permukaan or surface water, river. Alright. And you have sources of rivers, streams, lakes, ponds, and reservoir. Now, the issue with surface water, cabaran kepada air permukaan atau air surface water ni adalah, what is it? What is the issue? Sometimes you have silt and clay particles, you have predators, you have disease, you might have pesticides that comes down from agricultural areas or agricultural plots, and the quality varies with season, from season to season. Wet season, you might get the water very turbid because of the maybe leaching of the soil. Okay, and then maybe upstream you have logging activities, projek-projek penebangan hutan di hulu sungai boleh merosakkan kualiti air, right? Especially the rainy season. So that is called that's why the quality varies with season. Okay, all right. And then you have seawater source for aquaculture, which is your brackish water. And for your brackish water, there are some issues also with pump intake, where you pump your water, biofouling of intakes. Now, biofouling is essentially the barnacles that grow on your pumps, that grow on your cages. Okay, biofouling, right? Barnacles. Bahasa Malaysia kita panggil teritip. Okay, yang hidup melekat dekat jaring-jaring tu, jaring ikan boleh merosakkan penukaran air dan juga pump. Susah nak masuk air dari pump. So, biofouling, your salinity fluctuations up and down, according to your rainy and wet season or dry season, and increased potential for hydrocarbon contamination. What is hydrocarbon contamination? What is it? Any idea? What is hydrocarbon contamination in the ocean? Okay. Any idea? Siapa tahu?
Is it oil? Oil? Is it oil?
Is it what?
Oil.
Yes, of course. Oil slick, oil leak. Okay, tumpahan minyak. Okay, tumpahan minyak dari kapal kan, kadang-kadang pelanggaran kapal, accident kan dekat laut. So all those accident related to oil slick, oil leaks, tumpahan minyak, those things can increase your hydrocarbon contamination. All right. So if you pump water from the sea and that particular area have let's say an incident of oil leak, then you had it. You cannot pump the water anymore because the water is contaminated with oil, hydrocarbon lah. Yeah. So these are some examples of your water sources from the surface. Yeah. This is your reservoir, empangan. Look at that. You have lakes. Of course, you have very nice water from the sea. This is also an example of surface water sources. Have you guys been to our research station in Puchong? Have you? Or not yet?
Not yet.
Not yet, huh? Do you think you will be going there sometime with any other classes? Or not sure?
Not sure. Not sure lah. Yeah.
Would you like to go there?
Yeah.
Yeah. All right. So okay, you have not been there, then we have to plan for it lah. Okay, we can plan for you to go and take a look at the water sources. Now, there's now our hatchery, or not now they don't call it hatchery, they call it a research station, is on this side. Okay, near my cursor here, on this side towards this side. And this is a river that goes that flows in front of our research station. This river, it flows in front of our research station. Now this river, the color is greenish in color, right? Slightly green. But this is the source. The source is very clean, pristine, not contaminated. So this is the source of the water. Ni sumber air ni dekat forest reserve, air hitam forest reserve. Okay. Air sini akan menjadi kelabu macam ni selepas 2 km. Imagine this water here, very nice, clean, okay, and no contamination. After 2 kilometers downstream, the water becomes like this. All right. Now, what happened? The water went through some housing area, went through some area where they did some construction, some and then some earthworks. So the water becomes turbid like this. But originally, wow, very nice water, very clean. You can swim down here. There's a what do you call this? A waterfall here as well. All right. Now, 4 kilometers away. Now this is 2 kilometers away, right? 4 kilometers away, you see this. Even worse, very turbid. Now this is the green water from here. This one, this is green water. Okay, greenish. This is it, this one. And then from another side, this is water from a housing development area. Up here, they are developing a housing estate. And because of the erosion disebabkan oleh hakisan tanah, selepas hujan, air dia jadi warna coklat macam ni. So after it rain a lot, the water becomes very turbid. So this one is turbid with a lot of suspended clay particles, suspended inorganic particles. Di sini banyak kotoran buat dia turbid daripada tanah liat. Di sini turbid juga, tapi bukan turbid tanah liat. Di sini lebih dengan phytoplankton. Turbidity caused by clay particles. Turbidity caused mostly by phytoplankton. That's why it is a bit greenish here. Different. Both are turbid, but different source of turbidity. All right. Other than your surface water, you also have groundwater supply. Now, groundwater is what we use in our research station. In our research station, we use groundwater, which we pump from the ground. We don't use this for our research station because this water is contaminated. We use this from the ground because the water quality is better. But then we also have some problem. Even though water quality is better, less contaminated than this one, less disease and so on, less turbidity, but we have a problem with iron, zat besi. The groundwater that we use in our station has some high iron content. Okay, zat ferrum dia, kandungan ferrum, kandungan besi dia agak tinggi dan air dia warna kemerah-merahan. So the water is a bit turbid in the beginning when we pump. After a while it becomes clearer. But our groundwater here in Puchong tend to be reddish because of a high concentration of ferrum, high concentration of iron. All right. What else can you use? Okay, well, this I mentioned to you about groundwater. Okay, surface water. What are the pros and cons? Groundwater, these are the characteristic: low turbidity, absent or less predator, less exposure to contaminants, high mineral, low or no DO, high iron content, high hardness, high extraction cost. Extraction cost is cost to take it out. Cost ekstraksi atau cost nak keluarkan air itu nama dia extraction cost. Okay. Air permukaan, high turbidity, more predator and disease vectors, greater exposure to contaminants, low mineral content, DO present, DO ada sikit, ni kurang, low iron content, low hardness and low extraction cost. Alright, so these are the basic differences between groundwater and surface water, but you have alternative. If you cannot use your water from the river, okay, and then you cannot use your water from the ground because of high iron content, right? You can use other alternative. Rainwater, why not? But it's a bit acidic sometimes. Municipal water is what you get from the tap, and you can also use recycled water, water that you cycle and reuse and treat and reuse. So in aquaculture, the use of recycled water is gaining importance because we want to make sure that we minimize our water intake. Sometimes the more water we pump from the river, from the sea, the more disease we get. Okay, and because the water we discharge can impact the environment, it is better also to recycle the water. So rainwater, municipal water, and water that we keep on using or recycling. All right. But the key idea here is to understand that if you have water which is poor in quality, you obviously will have very poor harvest. Poor water quality, poor harvest. All right. Okay, so I want to stop there for today. We stop here. And then hold on. I'll continue later on. The rest of the slides in the next class. Tak banyak, sikit aja. Not many, but because this topic can be a bit confusing after this on tolerance range and so on can be confusing. I don't want to discuss it right now. Okay, we'll talk about it another day, next week. Right, so another thing I'd like to share with you. By the way, kedatangan okey Hatira ya? Boleh?
Okay, dah ambil dah je lah.
Okay. Now, I would like you to also take this kedatangan to another one also for lab. Now, I will not go through the lab class today. Lab is supposed to be at what time? 2 or 3? Forgot.
2.
2 p.m.
2 p.m. So I will not will not have the lab class online today. I need to do some stuff for the department. But your attendance will be taken as well as for the lab. Atira buat sekali ya. Hello.
Boleh sila. Kini sekalikan dengan attendance lecture ni lah.
Yeah. Meaning that whoever joins the lecture this morning is considered also has attended the lab later in the afternoon. Okay?
Okay.
Okay. Why? Because after this, I want to show you the lab lah. What you need to do. Boleh? Since I will not join you later, I will ask you to do the lab now. So that this lab you do in your group. Now, have you done? Okay, hold on. By the time being, have you break up into your group yet for the lab or not yet? Ada tak? Tak ada lagi
For water quality tak ada lagi.
Tak ada lagi Okay, so what I need you to do is to go in groups, okay? To break up in 6 groups. All right, 6 groups. Each group, okay, the student is between 5 to 6 per group. Okay. So setiap group ada 5 atau 6 student, maksima 6, minima 5 dan ada 6 group. So you give that list of students in the group to Atira. Okay, for this class. Okay, all right. So then for this lab, which I want to share with you, you need to do this in the next 1 week so that by the time we have our class next Tuesday, you already can submit your answers and your report. Boleh? Since we are not meeting face to face, so I thought I just give you a very simple assignment related to our topic today. Okay? And this is done on a group basis, depending on your group. All right? Okay, I want to show you what it is, and then I will share this in your WhatsApp. Okay, can you see this?
Yes, Ciklah.
So this is your lab for today. And then you just do it in a group, in your group, and submit to me, email to me by Wednesday next week, by Tuesday next week. Okay. All right. Now, what do you need to do? So in this particular lab, the purpose of this assignment is to make students become familiar with the physical, chemical, and biological water quality parameters that influence water quality in aquaculture. Remember, I mentioned to you earlier, physical, chemical, and biological water quality parameters. What were they? You mentioned to me just now, right? pH lah, DO lah, salinity, temperature, all those. Okay. So, I would like you in each group to list 10 water quality parameters which you think are very important for a fish farmer to understand and manage effectively. Okay? Saya hendak you senaraikan 10 parameter quality air yang you rasa, you think in your group, okay, you don't have to compare with other groups, you do in your group, what are the 10 most important water quality parameters you think that a fish farmer needs to understand and needs to manage effectively to grow his fish, his or her fish. What are the 10? You decide in your group, okay? And once you decide those 10 parameters, for each parameter, you want to write down why is it important. Why is it important for the well-being of your fish? Okay? Let's say you mention temperature, for instance. Temperature. So why is temperature important? Why is it? What happens when the temperature is too hot or too warm? When the temperature is too cold, what happens? So explain like that. Okay? So another thing I like to add in, okay, is here. What is the unit used to measure the concentration of water quality parameters you've listed? Okay. All right, meaning that, let's say you mention temperature. What unit do you use to measure the concentration of, or rather the scale? What is the unit or scale, better for you to understand? Used to measure the concentration of water quality parameters. All right. You don't say concentration for temperature. You say the range. Huh? Okay. Okay. What about temperature? All right. So temperature. When you say temperature, how do you measure temperature? What unit or scale do you use?
Celsius.
Celsius. Right. So Celsius. Some may use Fahrenheit. So that is the answer. So kalau temperature, Celsius. All right. So you may want to use a table lah. Okay, one table. You have 3 columns. It's up to your group lah. No, I leave it to you what you want to do. Make it nicer or easier for me to understand. So maybe in your table, the first column is the list of parameters. The second column is the scale or unit used. Number 3, and the third table is essentially the importance of it. Right. So 3 columns in the table, and that will be just fine for me to go through. All right. For instance, so that's temperature. So temperature is the parameter. The scale used is your Celsius. Okay. And then what is the range? How do you measure it? And then for your explain the importance, you can mention lah. So the range for temperature should be between how many degree to how many degrees Celsius. If you go below that, this is the problem. If you go higher than that, is the problem. Do you guys get it? Boleh?
Boleh je lah.
Boleh eh? It's not.
Boleh.
It's not complicated kan? It's quite straightforward.
Cik lah.
Alright. Yeah.
I want to ask regarding the format for our report, like the fonts and the sizing, spacing. Is that a specific?
No. For this first lab, you just do. You just show me whatever you think will be something for me, easy for me to see and read and understand. Is it okay? Is it all right?
Okay, Cik lah.
Okay. Font, I prefer normally for an old person's eye like me, font should be more than 12 points. Like now here, I have Calibri kan. You can use Calibri or you can use, what do you call this? Arial or New Times, New Roman. It's okay. I do not want to be specific with that. As long as it is 12 points and above, ni kan 14 points kan? See that? 14.
Yes.
So yeah, you can use 12 and above. 14 is good for me. In fact, 14. If you can use 14, it's good for my eyes lah. Okay. You know, I get dizzy reading all the small letters. All right. The bigger it is, the easier for me to read and understand and so on. So make it 12 and above. If you can do 12, it's fine. If you want to do 13 or 14, it's fine also. All right, but don't make it too small. Not 10. Anything below 12 is too small for me. 12 and above is good. I think that's quite standard also for our reporting lah. In terms of the font style, Calibri or Arial, you can use any, but make sure it's not so cursive or something that I cannot read lah. Boleh ya? Is it okay, guys?
Okay.
Boleh. These things are more like formatting and not so important. I want to see the inside here. I would like to see what is your thinking behind this. You're thinking on the 10 parameters. You're thinking on the range. the scale used and why is important. To me, that is more important than the format lah. Okay, we'll talk about format later on as we meet during what do you call it, face-to-face meeting. Then I will teach you a proper format for all this. But for the first few weeks before we meet face-to-face, I'll make it more flexible for all of you. Is it okay? Boleh?
Boleh.
Good. All right. Good. So this is your assignment. I will save as a PDF. All right, and then apa nama tu? You will share with you in your WhatsApp shortly. Okay. Anda buat PDF dah. Okay, so I think that's about it, guys. And then Tira will assist me with your attendance. And bagi dua-dua sekali Tira, ya? Hello? Tira? Ya. Alright.
Ya, je lah.
Okay, dengar kan? Boleh ya?
Dengar. Tadi bising sikit kat sini.
Okay, tak apa. Alright, so that's about it. That's about it. And then I hope you've learned something today. Did you guys learn anything today? Did you?
Learn a lot.
Lalu I must complain. Do my students learn from me or they just like okay, dia awang-awangan ke, zone out ke, you know? You learn something youngest today. I hope you did. Okay, all right. Semua, thanks a lot, guys, and enjoy your lunch. Catch up with you in another class. I'm sure I meet up with you tomorrow, kan? All right. Okay, so in the meantime, have a good day and enjoy whatever is remaining of it. All right? Thank you. Bye.